Okay, this is the quiz one for the AP review, multiple choice video one, and it'll be problems 1 to 10. All right, so this is quiz one and it's multiple choice. Of the following dot plots, which represents the set of data that has the greatest standard deviation? First off, remember that the formula for standard deviation is essentially the square root of x minus mu square root divided by n. So these are the individual data points. And obviously, the farther they are away from the mean, the larger the standard deviation. So the farther a data point is from the mean, the larger our standard deviation. So if our mean is basically in the center, the one that has the most data away from the mean and the smallest amount in towards the mean is B. So for the answer to number one, our answer choice is B. Okay? All right, moving on. Number two, a random sample of 374 United States pennies was collected, and the age of each penny was determined according to the box plot below. What is the approximate interquartile range of the ages? Well, remember, IQR equals Q3 minus Q1. So here's my Q1, here's my Q3. And so this is approximately 20, and I'm just going to take a guess that that's about 5. So if Q3, this is 20, this is 5, so 20 minus 5 happens to equal 15. So I'm looking for the one closest to 15, and I see that I have a 16, so that's the closest at letter C. And by the way, once again, it's an estimate, it's not going to be perfect. Number three, the histogram above shows the distribution of minutes needed by 45 students to finish playing a computer game. Which of the following statements is correct? The distribution is skewed. Well, okay, let's look at this thing. Which way is it stretched? Well, it's stretched to the left. So if it's stretched to the left, that means it is skewed to the left. And one other thing to note about this, that means the mean will be less than the median. So if the median were approximately here, and I'm just guessing, but if this is where the median is, the mean will be somewhere to its left, and the mean will be less than the median. And you need to keep that straight if we're talking about skewed to the right. That's really important. I mean, skewed to the left or skewed to the right. So this distribution is skewed to the left. So three, the answer choice to three is letter B. Okay, moving on to number four. A bank surveyed, this is really important, all of its 60 employees. So in other words, they conducted a census because they surveyed everybody to determine the proportion who participate in volunteer activities. Okay, so one thing is in statistics, if we actually have a census, we actually have conducted a true census, we know the true population proportion, and as a result, we don't need to do any inference procedure. So the bank does not need to use an inference procedure to determine the proportion of employees because we actually know the true amount. Because when you do the census, you know the actual population, assuming you can conduct one. All right, number five. The histogram below shows the frequencies of waiting times in minutes for 175 patients in the dentist office. Which of the following could be the median? Well, remember the median is the middlemost number. So if I have 175, I divide it by 2. 175 divided by 2. I end up with my middlemost number is going to occur at the 88th person because this is 87.5. So basically the 88th. All right, so what do I need to do? This tells me I have 80 people about here, and here I have about 40 people. So somewhere in this bar, I don't know where, it could be as low as 5 or high as 10, is my median. So my median is going to be 5 less than the median less than 10. Well, the only choice between 5 and 10 is B, 7.25. Also, one other thing to point out about this is skewed to the right because it's stretched to the right. And with that being the case, the mean will be greater than the median. The mean is right of the median. So let's think about what that means. Mean is right of the median. If my median is here at 7.25, my mean is going to be somewhere right of that. It's going to be somewhere over here. It's going to be the right of 7.25. Anyway, the answer choice to number 5 happens to be B. And okay. Number 6, data were collected on the amount in dollars that an individual customer spent on diner in an Italian restaurant. The quartiles for the data are given below. So we have Q1, which is 25%. Q3 is 75%. And we usually don't refer to it as Q2, but this is the 50th percentile, which is also known as the median. So half the values are smaller than 44 and half are larger. So at least half of the values spent less than or equal to 40.27, and at least half spent greater than or equal to 44.27. And since that's the median, half spent less, half spent more. So for 6, we like A as our choice. Number 7, the weight of adult grizzly bears living in the wild in the continental state is approximately normally distributed with a mean of 500 pounds and a standard deviation of 50. So this is the males, and we have a mean equal to 500 and a standard deviation equal to 50. The weight of the adult female bears is approximately normally distributed with a mean equal to 300 pounds and a standard deviation of 40. Approximately what would be the weight of a female grizzly bear with the same standardized score as a male grizzly bear with a mean of 530? So we have an X equal to 530 here. So let's go ahead and calculate a Z-score. Now they told us they were normal, but really wasn't necessary because we're not actually calculating probabilities. If we're calculating probabilities, that would be normal. We need to know that they're normal. But since we're not, since we can just use a Z-score, we didn't need to know that, but it was nice. 530 minus 500 over 50. And when I do that, 530 minus 500 divided by 50, and I end up getting a Z-score equal to 0.6. So we're going to do the same thing for the female bear, but in this case, we don't know the weight, but we know that the average weight is 300, the standard deviation is 40, and we wanted the same standardized score. All right, so we're just bringing this 0.6 up to right there. So solving using algebra times, 0.6 times 40, and then add the 300. And I end up getting that the female grizzly bear needs to weigh 324 pounds. And then it's also 0.6 standard deviations above the mean. So this bear, the 530 is 0.6 standard deviations above. The female bear at 324 is 0.6 standard deviations above. Number 8, the company sells concrete in batches of 5 cubic yards. The probability distribution of X, the number of cubic yards in a single order, is shown below in the table. And we're going to do a little extra work with this one just because I think it's going to be necessary in the future. and you may need to know it for FRQ or multiple choice. So the expected value of the probability distribution is 19.25, and the standard deviation is 5.76. So let's figure out how they did that, because you are going to need to know how to do that. So if I go to stat edit, and I put in 10, 15, 20, 25, and 30, 0.15, 0.25, etc. here, and I go stat calc one variable statistics. My list is L1 and L2. Sure enough, I get 19.25 and 5.76. And I'm going to pause this for just a moment. All right, having thought about it, I'm going to continue on with what we're doing right now, and then I'm going to show you a little extra work. I just wanted to make sure that we could actually calculate those. So we calculated the 19.25 and the 5.76. The profit Y in dollars for the particular order can be described by Y equals 75x minus 100. So Y equals 75x minus 100. And they ask for what's the standard deviation for Y. So at this point, we already have the 5.76, so I can plug that in there. Y equals 75 times 5.76 minus 100. Now, I can multiply. Now, standard deviation is a measure of spread. And I can multiply measures of spread by constant. So this is okay to do. But I cannot add or subtract a constant, so this goes away. So my standard deviation is just going to be 75 times 5.76. And that gives me 432. So this is my answer. Now, had they asked me for my mean, I would have done something slightly different. So this was the standard deviation. If they had asked me for my mean, my equation is still Y equals 75 times X minus 100. And I'm going to plug in the mean, which is 19.25. So 75 times 19.25 minus 100. Now, with measures of center, and this is a measure of center, this is a measure of spread. With measures of center, I can multiply by a constant, and I can add and subtract constants. So for the mean, I would have just gone 75 times 19.25 minus 100. And this would give me that large value of 1,343.75. And that would be the mean of Y. Okay, so that's using the calculator. But on an FRQ test, they're going to expect you to show your work. So how would I show my work to calculate the mean? So to calculate the mean, I would just do this. Equals 10 times 0.15 plus 15 times 0.25 plus plus 30 times 0.05. And if I did that and did all that work using the L1 and L2, I'm going to end up getting what we previously got of 19.25. So that's how I would show the mean. On the other hand, if I wanted to show the standard deviation, it becomes a little bit more work. And the standard deviation would be, first off, everything's going to be under the radical. So I'm just going to draw a giant radical sign. And my first value was 10 minus, what was my mean? 19.25. I'm going to square it, and I'm going to multiply it by the associated probability, which is 15. Plus 15 minus 19.25 squared times the probability of 0.25 plus plus 30 minus 19.25 squared times the 0.05. And if I'd done all that work, I would have gotten 5.76 when I came back around. This is the way you show your work for the expected value and the standard deviation. If you just plug it in L1 and L2 on an FRQ, you'll get no credit. So you need to know how to show your work. This is really, really critical that you know how to do this. Now on a multiple choice, if they ask me to do it on multiple choice, I'm using L1 and L2 and showing as little work as possible because I'm under a time crunch. All right, you don't have to show the work. Number 9, based on a survey of a random sample of 900 adults in the United States, a journalist reports that 60% of the adults in the United States are in favor of increasing the minimum hourly wage. If the reported percent has a margin of error of 2.7, which of the following is closest to the level of confidence? So first off, here's our confidence interval formula. P hat plus or minus Z star, P hat, Q hat, N. This part right here is our margin of error. Well, in this case, they're telling us our margin of error is 0.027. We know that they say that it was 60%. So P hat is 0.60. Q hat's 1 minus that, so that's 0.40. And our sample size was 900. So what we need to calculate is Z star. So let's go ahead and calculate this part under the radical. So 0.6 times 0.4 divided by 900. And I'm going to take the square root of that. And I get 0.01632. And I'm going to take the 0.027 and divide it by what we just calculated. So 0.027 divided by what we just calculated. And I end up getting a Z star of 1.653. So Z star equals a plus or minus 1.653. You're like, why is it plus or minus? Because we have a plus or minus right here. So here's what we are looking for. We're drawing a normal curve and we're calculating the Z-scores. All Z-scores are centered on 0. So we have a upper bound of 1.653 and a lower bound of negative 1.653. And I'm looking for the area in between. So here we go. We can do this using a norm CDF. Negative 1.653 is my lower bound. My upper bound is 1.653. I have a mean of 0. And since it's a Z-score, my standard deviation is 1. So second vars, norm CDF, second vars, norm CDF, negative 1.653, 1.653. And we end up finding this area to be 0.9016. So which one of these is closest to that? When I see that, letter B or 90%. This is about 90%. Number 10, a compact disc manufacturer wanted to determine which of 2 different cover designs for a newly released CD will generate more sales. The manufacturer chose 70 stores to sell the CD. 35 of these stores were randomly assigned. So we randomly assigned to sell one CD, and the other one was randomly assigned to sell the other CD cover. The manufacturer, and so notice we have random assignment of the 2 stores. The manufacturer recorded the number of CDs sold at each of the stores and found a significant difference. So the difference is significant. We have random assignment, which means we did an experiment, and the difference was significance. Which of the following gives the conclusion that should be made based on the results and provide the best explanation for the conclusion. It is not reasonable to conclude because they say this is not an experiment. No, this is an experiment. There was no control group. You don't have to have a control group, but you do have to have a group for comparison. And we had 2 cover designs, so we did have a comparison, so that's not false. And so that is also false. Okay. It is not reasonable to conclude that the difference was caused by the different cover designs because the 70 stores were not randomly chosen. Doesn't matter about the 70 stores. It matters that we randomly assigned within the 70 stores. It is reasonable to conclude that the difference in sales was caused by the different cover designs because the cover designs were randomly assigned. This looks pretty good. It's reasonable to conclude that the difference in sales was caused by the different cover designs because the sample size was large. No, just because you have a large sample size doesn't mean it's reasonable to conclude. It has to be statistically significant as well. In this case, it was statistically significant. We had random assignment, so we had an experiment, and we can generalize this to similar type stores. Can't generalize it to all stores or all places, but you can generalize it to stores like this, okay? So as similar as possible to that. All right. Thank you.